So the last little thing we have to talk about before your quiz, which again, quiz is on Thursday, is identifying different shapes of distribution. So one thing here, when we're talking about shape of distributions, it's always dealing with quantitative data. Because with quantitative data, right, you have your x-axis labeled in such a way where all your bars, like they would be the same order no matter what. All your data would be in the same order no matter what if you go from least to greatest. With qualitative data, you can really organize like your bars and your bar graph any way you want. So it's kind of hard to determine a distribution when you can rearrange your graph any way you want. So distributions are only with quantitative data. So a useful way to describe a variable is by the shape of its distribution, which we can determine just by looking at it. So some common distribution shapes are, first is called normal, or sometimes it's called symmetric, or bell-shaped. It has a bunch of different names. Normal is the main one, and we're going to be dealing a lot with the normal distribution later on this year. The second common one is uniform. And then our last two are when our data is skewed. So we have skewed left and skewed right. Okay, so when we are identifying a distribution, it's just the general shape of the graph. You don't have to go into all the little details and the ups and downs, it's just the overall general shape. So we say a variable has a uniform distribution. When each of the values tend to occur with the same frequency, or it's straight across, all your bars are the same height. So it makes kind of a rectangle. And again, they don't all have to be exactly the same in order for it to be uniform, as long as if they are all close to being the same, it could still be uniform. A variable has a normal distribution. When most of the values fall in the middle, and then the frequencies kind of tail off as you go to the right and the left. So again, if you were to draw a general shape around it, it would look kind of like a bell, hence bell shape. Okay, then on the next page is our skewed data. So a variable is skewed to the right. So it's a skewed right distribution when the distribution is not symmetric and the tail to the right is longer than that of the left. So the way it's skewed is whatever way the tail is going. So most of the data is to the left, but then there's this data off to the right that's pulling it over and preventing it from being symmetric. So whatever side the tail is on is the way it's skewed. So being skewed left just means your tail is to the left. So again, most of your data is to the right, but then there's some to the left pulling it over. Okay, so again, identifying a type of distribution requires you to look at the general outline of data, not the specific details. So again, compare your sketches and how you labeled them. I have what I labeled up here. Again, the idea is a very general shape, the very big general outline. We don't care about the little ups and downs that happen in the middle, just a very general curve. All right. So now, if you guys go to the next page. So usually when we have these distributions, again, it has to deal with quantitative data. So I have here in these boxes just some examples of data that was gathered. And I want you to, you can work with the people around you to read through these variables and just make a guess as to what you think the distribution would look like. So for example, like letter A, the age in years of everyone in a high school. So you just have to think, do you think everybody in a high school is going to be about the same age? Well, what are the types of people that are in a high school? There's teachers and then there's students, right? Is there a lot more students than teachers? Yes, and students are younger than teachers. So that means if we had our axis here, the younger ages would be over here, if I could spell young correctly. And the older ages are going to be over here, so there's going to be a lot of students and then a little bit of some teachers. So it's just a guess of what you think the distribution would look like. There's no right or wrong answers here, just a guess. So take a minute and work with the people around you to just draw those sketches, again, very general, of what you think these distributions would look like. So now with these variables in mind, we're going to go back through, because these are all variables that were used to get the graphs that I've flashed up here for a minute. So we're going to go back and look at those graphs and try to match which of these variables goes with each graph.